Hello boys and girls, welcome to CubeRoot Learn, and in this video we will be learning about class 10 chapter number 1 real numbers, and this is the part 2. What about revisiting irrational numbers? You have learned about irrational numbers when you are in 9th grade, that root 2 is irrational, root 3 is irrational, but in this video we will be learning how to prove that these numbers are irrational. A rational number can be expressed in the form that is p divided by q, where q is not equal to 0, right? This is what rational number which can be represented as p divided by q and q not equal to 0. This is a rational number, right? Irrational number means they cannot be expressed in the form of p divided by q. That is a rational number. So we have to prove that root 2 is irrational. So for that, what will you do? First, let us assume that root 2 is rational. Okay, we are assuming that root 2 is a rational number. Okay, and in the beginning itself I've told a rational number can be written in the form of p divided by q. So in the same way, root 2 can be written as a divided by b. Instead of p and q, you can write any variable, it's fine. A divided by b, where a and b are co-prime numbers. What is co-prime numbers? Their common factors are 1. No other numbers they have as common factors. 1 is their common factor. Now what you're gonna do is we're gonna take this b to the other side. Okay, so I've written b root 2 equals a. Now we're gonna square it on the both sides. Okay, so what will you get? You will get b square into root 2 square is 2 equals a, right? So we have 2b square equals a square. Okay, so here you can write it as a square is divisible by 2. So a is also divisible by 2. If you're wondering how, right? It is written a square equals 2b square, right? So a square is a product of 2 into b square. So a square is divisible by 2, right? For example, you know that I'm taking a random example, that is 16 equals 2 into 8, right? So 16 is divisible by 2, right? It is 2 into 8 equals 16. So 16 is divisible by 2, right? I hope you're getting what I'm trying to say. Here, a square is divisible by 2. So a is also divisible by 2. Now, since a is divisible by 2, we can write that let a equals 2c for c is an integer. How did that happen? Since a is divisible by 2, a can be written as a factor of 2 into some other number, right? That is c. I hope it is clear. Since a is divisible by 2, it's a factor, right? So a can be written as 2c. Okay. So you know that a square equals 2. This is your first equation. Okay, I forgot to write that. You know that a square equals 2b square, right? And you have a equals 2c. So a square equals, you can write it as 4c square, right? See, a square equals 2b square, we already written it from here. Then you have a equals 2c. So a square equals 4c square. We just did the squaring of this. Okay. So here a square equals 2b square and a square equals 4c square. So we can write it as 2b square equals 4c square, and we can divide it by 2 because 2 is common. So we will get b square equals 2c square, right? So what does that mean? We have 2b square equals 2c square, right? So what does that mean? B square equals 2c square, that is b square is divisible by 2, right? Divisible by 2. So therefore b is also divisible by 2, right? You know b square is equals 2 into c square, 2 into some number, right? So b square is divisible by 2. So the same way it implies for b is also divisible by 2. Okay. So this is equation number 2. So if you see from equation number 1, A is divisible by 2, B also divisible by 2, right? So what does that mean? A and B are divisible by 2, and this contradicts the fact and the assumption that A and B are co-prime numbers. In the assumption we have taken that root 2 is rational, so root 2 can be written as A divided by B, where A and B are co-prime numbers, where only one is the common factor and it cannot be divisible by any other number. But here we have proved that A and B are not co-prime. A and B are not co-prime numbers, right? So what does it mean? Our assumption is wrong. This contradicts the fact that assumption is wrong. So our assumption is wrong. So root 2 is irrational. See, it's nothing but here what you've done is here we just assume that root 2 is rational and it can be written in the form of A divided by B, where A and B are co-prime. We just proved that A and B are not co-prime. Why it is not co-prime? Because A and B are divisible by 2. They have a other common factor, that is 2. And this contradicts the fact and assumption that A and B are co-prime, right? Since our assumption is wrong, right, we just assumed that root 2 is rational. Our assumption is wrong. When we prove, we realize that assumption is wrong. So it means that root 2 is irrational. Okay, I hope this is clear. The same way only you can prove how root 3 is also rational. For now, let's move on to exercise 1.2. And the first question is to prove that root 5 is irrational. So let us assume that root 5 is rational. Okay, so root 5 can be written as A divided by B, where A and B are co-prime numbers. What is co-prime? Co-prime is nothing but the numbers which only have one as their common factor, and so that is co-prime, and root 5 equals A divided by B. So we just taken the B to the other side. So write it as B root 5 equals A. We'll do squaring on both sides. So what will you get? You will get 5b square equals a square. So we have 5b square equals a square. So what does it mean? A square is, since it is a square equals 5b square, it simply means that a square is divisible by 5 and a is also divisible by 5. Therefore, a is divisible by 5. This is first part. Since a is divisible by 5, we can write as let us write that let a equals 5a. Right. A divisible by 5 means a is a fact. A equals 5 into some other number, right? C is an integer. Okay. We are writing this because a is divisible by 5. So we can write it as a equals 5a. C. Okay. We know that a square equals 5b square. Right. And you know that a equals 5c, right? Can do squaring over there and you can write it as a square equals 25c square, right? Since a square and a square over the left hand sides are equal, we can write it as 5b square equals 5c square. 5b square equals 25c square. We'll divide by 5. What will you get? You will get b square equals 5c square. Since b square equals 5c square, it means that b square is divisible by 5 and b is divisible by 5. If b square is divisible by 5, so obviously b will also be divisible by 5, right? Okay. So this is equation number 2, right? This statement. So from this we have analyzed and understand that a and b are divisible by from 1 and 2. A and B are divisible by 5. From our assumption, A and B are co-prime numbers, right? So this contradicts. This contradiction is arisen because of our wrong assumption. We have assumed that root 5 is rational. So it can be written in the form of A divided by B, right? But now we just proved that, and we have already told that A and B are co-prime also. But we just proved that A and B are not co-prime, they are divisible by some other number also, right? In this case, this contradiction is happening because of our assumption is wrong. So we have assumed that root 5 is rational. That is our wrong assumption. So root 5 is irrational. And second, I'm telling you that we in the question in the beginning we have assumed that root 5 is rational. Okay. And we have told that root 5 equals a divided by b, where a and b are co-prime numbers. But we just proved that a and b are not co-prime. They're divisible by 5, right? So our assumption is wrong. This contradiction has happened that because our assumption is wrong. Since we have told that root 5 is rational, which our assumption is wrong, it simply means that root 5 is rational. I hope this is clear. This kind of proof is called contradiction kind of proof. I hope this question is clear. This is the second question, that is prove that 3 plus 2 root 5 is irrational. So let us assume that this is rational. Okay, since it is rational, we can write it as 3 plus 2 root 5 equals a divided by b, where a and b are co-prime numbers. Okay, we write it as 2 root 5 equals a divided by b minus 3. You have taken this 3 to the other side. Okay, so when you take the LCM, we have 2 root 5 equals a minus 3b divided by b. Now we'll take this 2 over here down to the denominator. So what will you get? We'll get it as root 5 equals a minus 3b divided by b. 2b, okay? So we have root 5 equals a minus 3b divided by 2b. We know that a, b, 2 and 3 are integers, right? We know these numbers are integers, right? A, b, 2 and root 3 are integers, right? So a minus 3b divided by 2b is a rational number. Why is it a rational number? Because a, b, 3 and 2 are integers. They all are integers, right? Integers are written like this in p by q form, where q is not equal to 0. Then only it will become a rational number, right? So a minus 3 divided by 2b is a rational number, and we know that root 5 is an irrational number, right? We know that root 5 is an irrational number, right? So what is this? This contradicts the fact, right? This contradiction is arisen because of our wrong assumption, right? So this means that 3 plus 2 root 5 is irrational number. See, you know that this is a rational number, right? And we already know that root 5 is irrational number, right? A rational number and irrational number, they both never can be equal, right? So there's a contradiction, right? That is root 5 equals, this is an irrational number equal to rational number. There is some kind of contradiction, right? This contradiction has happened because of what? Because our assumption was wrong. What did we assume? We assumed that 3 plus root 5 is rational. Since our assumption is wrong, so because of that, 3 plus 2 root 5 is irrational, and I hope this is clear. This is the third question. Prove the following are irrationals, and this is the first part, that is 1 by root 2. What's the first step? Let us assume that 1 divided by root 2 is rational number, okay? So we can write it as 1 divided by root 2 equals a divided by b, where a and b are co-prime. If we see here carefully, we can write it as b divided by a equals root 2, right? How did I do that? I just did cross multiplication, right? I just exchanged this, so it is b by a equals root 2, right? Again, you know that root 2 is an irrational number, right? Yes or no? Yes, it is a rational number. B by a is rational, right? Because b and a are integers, and we already written that a by b 1 by root 2 equals a by b. If you want to write a by b, then it should be rational, right? So b by a is also a rational number, right? This is a contradiction, right? B by a is a rational number, right? And you know that rational number is not equal to an irrational number, right? And root 2 is irrational, you know that. This contradiction is arisen because of our wrong assumption, okay? We assumed that 1 by root 2 is rational, and because of the contradiction we realized that this is the wrong assumption. So see, either a number can be rational or rational, right? So if you assume that it's a rational and it is wrong, then there is only one option, that is it is irrational. So 1 by root 2 is irrational. This is the second part. That is, you have to prove that 7 root 5 is irrational, okay? So let us assume that 7 root 5 is rational number. So 7 root 5 can be written as a divided by b. A and b are co-prime numbers, okay? Now I've taken this 7 to the other side. So root 5 equals a divided by 7b, okay? You can see here that a, b and 7 are integers. A divided by 7b is a rational number, right? And root 5 is irrational. And we have written here that root 5 equals a divided by 7 root b. That is a contradiction, and that is never possible, right? A rational number equal to an irrational number. So, what does it mean? This contradiction is arisen because of our wrong assumption. We assumed that 7 root 7 is a rational number, so our assumption is wrong. So therefore 7 root 7 is irrational. I hope this question is clear. Moving on to the next question. This is the last question of this exercise and last question of this chapter. Let us do this. We have to prove that 6 plus root 2 is irrational, okay? So our main step, that is, let us assume that 6 plus root 2 is rational number, okay? So this can be written as 6 plus root 2 can be written as a divided by b, where a, b are co-prime numbers, okay? Now written root 2 equals, I've taken this 6 to the other side. A divided b minus 6. So on taking the LCM, we'll have 6a minus 6b divided by b, right? And you know that a, b, 6 are integers. A minus 6b divided by b is a rational number. And we know that root 2 is irrational, right? And it is written that these two are equal, and that is never possible, right? So there is a contradiction, right? So this contradiction is arisen because of our wrong assumption. What was our assumption? Our assumption was 6 plus root 2 is rational, but that assumption is wrong. So it means that 6 plus root 2 is irrational. So this is the end of the video and end of the chapter. We have completed the chapter real numbers. We have done both exercises. And if you have any suggestions or feedbacks or queries, please feel free to write it down in the comment box. And please also do mention which chapter do you want me to cover in the next video. Thank you so much for watching. Happy learning.